What does this even say? Radians. You guys, you may probably have never seen it. You with me, Lil? You probably never seen it because we're just used to using degrees to talk about angles, ready? And so if I am cute little angle and I go like this, how many degrees would you say I went around? 360. What about this way? 360. Still 360 degrees, right? So we're so used to degrees. But it could also just be radians. And so I'm going to tell you, if I do a full rotation, 360 degrees is called 2 pi radians. How many people are like, why would we have to do that? That's terrible, right? So 2 pi is a full rotation, just like Mr. Richards wrote here. 1 pi radian is 180 degrees. So half of a circle is just 1 pi. So it's just another way to measure an angle. Now, you're saying, like, why do we even have to use pi? What shapes typically have pi in any other formulas? What shapes? Circle. What's the area of a circle? You don't have to write this down. Area of a circle is pi r squared. What's the circumference of a circle? 2 pi r. So you guys, don't you agree when we're talking about angles, if we're talking about rotations, they're pretty circular. So that's why they do put radians as just another way to measure parts of a circle, because circles do use pi. Now, in order to turn any degree into radians, you just take any degree. Let's go ahead and say like 45 degrees. If we want to know how many radians that is, 45 degrees, you just multiply by this pi over 180, and that's going to tell us how many radians. You guys, what I don't want you to do is type into your calculator that pi though. So if I were you, I'd say, I'm just curious, what is 45 over 180? And that's telling us we got 1/4 pi, or that's the same as pi over 4. So let me say that one more time. 45 degrees, I feel like you guys are pretty good at knowing, 45 degrees, boom, it's about that big. This is 45 degrees. That's the exact same thing as saying pi over 4 radians. And you're like, well, I'm really comfortable with this, so let's just leave it like that. I don't blame you. We're going to just expose ourselves to this a little bit this year. We don't have to be masters of it, but just so that you have seen radians. So again, this is just, we'll multiply by pi over 180 to get into radians. And then in order to go backwards, converting radians to degrees, we just do the opposite. So check this out. If I have 7 pi over 9, in order to turn into degrees, do you agree we got to get rid of our pi's? So I'm going to, now that pi is going to be on the bottom, and I'm going to multiply by 180 over pi. So go ahead and write that on that second part. Maybe actually right next to this, to convert from radians to degrees, we multiply by 180 over pi. That's kind of our big takeaway right there. So if we were to do that right here, guys, let's go get our calculators. Let's go grab our calculators, and how would we want to type this in? So we're going to multiply this one by 180 over pi. Do you guys agree these pi's are going to cancel? Boom, boom. So all I would type into my calculator is 7/9 times 180. That's what I would type into my calculator. I'm going to go hit 7/9 times 180. And that gets me 140 degrees. So they're the exact same thing. Like me calling Mateo or me calling him Holloman. It's the exact same thing. What about 7 pi over 10? If I've got a pi in it and I want to turn that into degrees, I'm going to take 7 pi over 10, multiply by 180 over pi so that my pi's cancel out. And I'll multiply 7/10 times 180.
126.
Beautiful. 126 degrees. Perf. When it just says 3.5, this one doesn't have a pi in it. Do you agree? We still do the exact same thing. Times 180 over pi. We'd still just multiply by that. I feel like this multiplication sign looks like a decimal. So I'm going to get rid of it. 3.5 times 180 over pi. And honestly, I would use the pi this time. Let's go do 3.5 times. Okay, we get an ad. Got an ad. What's up, bub?
Where's the, oh,
Second,
I found it.
right above the division sign. I'm okay with you guys getting decimals. I got 200.5 degrees because I actually used the pi in that one. You guys okay with that?
Yeah.
If there's no pi to cancel out, then we'll just put it in the problem. Cool. Now to go back into radians. To go back to radians, you guys, radians are the ones that do include pi. So maybe you write yourself a little note on this one. This is the one when we multiply by pi over 180. We don't want that pi to cancel out. That's how we do it on this guy. Okay, so 45 degrees. Let's go put that into radians. We're going to say 45 times pi over 180. Guys, I would not type that pi in your calculator. I wouldn't type it in, so how would I type this in with leaving the pi out? What could I type in? 45. Yeah, I could totally just do two different ways. We could do 45 divided by 180 to get 0.25 or 1/4. So that's one way to do it. So we could say 1/4 pi, or that's the same as pi over 4. Anyone else have a different way they might do it?
Did you put in 3.14?
3.14. Oh, yeah. I want to leave the pi out, but you're right. You could. But let's leave the pi out. I don't even want to type that in. I'm just saying here, maybe some people might say, I have 45 times 1 over 180. If you were to keep that pi out, that's just another way that we could have done it. 45 times 1 over 180 still gets us that same answer. So let's go ahead and say that's the same as pi over 4 radians. Let's try that again. 160 degrees. Whenever it doesn't have that pi in it, let's go ahead and multiply by pi over 180. A step skipper for us. Keep that pi out, and let's just do 160. So many ads. I kind of like that music. Yeah, did you do math enter on? Did you get 8/9 done? Cool. So let's leave it like that. You guys, we're going to have 8/9 pi. Another way you could write that is 8 pi over 9. Boom.
So we just aren't supposed to mess with the pi.
Keep the pi out.
Can it just be 8/9 pi?
Yeah, girl. Like that? Yep. 475 degrees. 475 times pi over 180. Leave the pi out. So this time I'm really doing, I flipped those around, didn't I? 475 divided by 180. What's that getting us?
36.
Wow, 95/36 pi. That's disgusting. And again, just so you guys know, this is just another way to write an angle instead of a degree. It's just a different way to do it. So what I want us to do is I'm going to teach you a trick. Do you want to do that? Okay. I just want you off to the side. Up here. I know this looks gross, right? Up here, I just want us to do 2 of these. Then I'm going to show you a trick. 30 degrees. How am I going to turn 30 degrees into radians? Off to the right. You guys, if we're trying to go into radians, we multiply by pi over 180 so that the pi will be there. 30 divided by 180. Help me out. Yes, that's going to get us 1/6 or pi over 6. I'm going to label it as pi over 6. Okay. What about 45? We don't even have to write it off to the side. If I had 45 times pi over 180, how would I figure out that one?
Isn't that pi over 4?
Yeah, you already remember it. He said, I just did that problem. I remember it. It's just pi over 4. 1/4 pi. Oh my gosh. Pi over 4 gets us 45 degrees gets us a pi over 4. Let's do one more. 60 degrees. Pi over, close, 3. 90 degrees. Yes, pi over 2. 120. 2 pi over 3. 135. Oops. 3 pi over 4. He says, okay, before you keep typing these in our calculator. Yeah, you could always type them in. I just want to show you a trick. Check this out. If we just go by, I want to show you the 1/4. This 45 degrees is 1/4 of a pi, right? What if I add 45 plus 45? Doesn't it get me to 90? What's 1/4 plus 1/4? 2/4 is 1/2, right? What is 1/4 plus, and then 1/4, 2/4, 3/4? What about adding 45 more degrees? What would that get me to? So if I go 1/4, 2/4, 3/4, 4/4 pi is the same as just 1 pi. If I wrote it as 4/4, don't you agree 4/4 isn't necessary? We could just say it's 1 pi. So you guys, every 45 degrees, you just add 1/4 of a pi. So check this out. We got a 1/4, then a 2/4, then a 3/4, then a 4/4. What about here? 5/4, 5/4 pi. What about down here? 6/4 pi. Oh wait, 6/4. How would I rewrite 6/4? I don't want to write 6/4. 3/2, right? 3 pi over 2 is 6/4 simplified. So literally in honors pre-calc, this is exactly what we do, and this is exactly how we count. We go 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. What's here? 7/4. And what would we end with? What's 8/4 the same as? 2 pi. 8 divided by 4 is 2. So we start at 0 radians or 2 pi radians. So when you count by 45 degrees, you go up by 4ths every single time. What do you think we go up by if we're counting by 30 degrees? 1/6. What's 2/6 the same as? Is that the same as 1/3? Yes. What would be 30 more degrees? 30, 60, 90. Wouldn't that be 1/6, 2/6, 3/6? Is 3/6 a half of a pi? 1/6, 2/6, 3/6. What about this one? 4/6. Is 4/6 the same as 2/3? Yeah. 1/6, 2/6, 3/6, 4/6, 5/6. So we're going to put that guy in. Every 30 degrees, we add 1/6 of a pi. So I love to have my pi over 4 stuff in there as a little landmark. Is one more time, ready? 1/6, 2/6, 3/6, 4/6, 5/6. What would this one become? 6/6 is the same as 1, right? 7/6. Abby is getting it. 7/6. What about that guy? 8/6 is 4/3. 30 more degrees gets me here. So again, I'm going to just count. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6. Is that 3/2? Is 9/6 the same as 3/2? If we divide them each by 3, yep. So that I love that little landmark there. Add a 6th again. What's 9/6 plus 1/6? 10/6. How would I rewrite 10/6? 5/3. 5 pi over 3. 10/6. What would this guy be? 11/6. And then finally, plus one more 6th was 12/6. 12 divided by 6 is 2 pi. You got it. Love it. So we'll practice more of that tomorrow. This did not copy very well. Bless you. This is 7 pi over 8. Guys, all I want you to do, it says convert the following from radians to degrees. And then, oh, these are all radians. Interesting. So in order to go 2 degrees, do you agree that we don't want the pi? We don't want the pi. So you guys, we're always going to multiply by 180 over pi. That's how you're going to get rid of that pi. Boom, boom. You do those 5 problems. We done.